Everyone. So today we're going to talk about neutralization calculations. And if you think about this word neutralization, what we're doing here is we're getting to a pH of 7. Now, in order to do that, we have to have our moles of acid equal to our moles of base. And I'm talking about moles of H plus equal to moles of OH minus. So we already talked about neutralization reactions and what they look like. And so when an acid and a base react, they produce salt and water. So it looks like this is a general kind of neutralization reaction. We have any acid reacting with a base to produce water. So this water comes from the proton from the acid and the hydroxide from the base. And then we also get a salt. Now remember, the salt here is any ionic compound. So the cation comes from the base, that's our positively charged ion in the salt. And then the anion comes from the acid, and that's our negatively charged ion from the acid. Now remember, since these are ionic compounds, you have to balance charges when you form these products. So you have to look at your periodic table, you have to look at your polyatomic ion sheet, and make sure that you're balancing charges before you balance that overall chemical reaction. So when these things neutralize, like I said, the moles of acid or H plus have to be equal to the moles of base OH minus. When these things are equal, they neutralize because they become water, and therefore we get a pH of 7. So remember, we have that molarity equation that we learned last unit. Our molarity equals moles divided by volume. If I solve for moles in this equation, I get molarity times volume. I just multiplied both sides by volume. So if I want to solve for the moles of acid, I get that the molarity of the acid, big M sub A, times the volume of the acid, big V sub A. And then I also have this factor coming into play, the number of acidic hydrogens. So we know that if I have, say, I don't know, a 2 molar concentrated HCl solution, that's only 1 hydrogen, right? So that concentration will also be the concentration of the hydrogen ions. However, if I have something like I don't know, sulfuric acid, that is H2SO4, right? So since there's 2 hydrogens in that acid, whatever concentration of that acid I have, I actually have a greater number of moles, 2 times the number of moles of hydrogen in that however many moles I have of that acid. So that's why we have to multiply it by the number of hydrogens here, because that will be the number of moles of acid or acidic hydrogens I actually have. And then moles of base, same thing. We get the molarity of the base times the volume of the base times the number of hydroxides there. Now, because for a neutralization calculation, the moles of acid has to equal the moles of base, I then just set these two equations equal to one another, and I get this equation right here. So we're going to do one example today, and that's it. Now, here's my example. Let me move myself so I'm not distracting you. A 25 milliliter solution of sulfuric acid, H2SO4, is neutralized by 18 milliliters of 1 molar sodium hydroxide. Write the neutralization reaction and what is the concentration of sulfuric acid. So my neutralization reaction, remember, I get my acid plus my base. My 2 products are my water, and salt, a salt, okay? So remember that salt, I have the cation coming from the base, and then that is going to be combined with the anion coming from the acid. Now remember, we have to look up charges here. So I know that sodium is a positive 1 charge. I know that sulfate is a negative 2 charge. So my sodium sulfate will be N2SO4. So this is what my overall chemical reaction looks like. Because I have N2SO4 over here, I have to balance the chemical reaction. So I get a 2 in front right here with my sodium. And then because I now have 4 hydrogens over here and I have 2 oxygens here and 4 oxygens there, I have to put a 2 in front of my water as well. Now, my next step here is I want to use my neutralization equation in order to find the concentration of sulfuric acid. So I am solving for this M sub A, this molarity of the acid here. Now, I know that my volume of the acid is 25 milliliters, all right, because it says a 25 milliliter solution of sulfuric acid. So that's going to go here. Now, if I look at sulfuric acid, I can see that I have 2 hydrogens right here. So I have to put a 2 right here as well. That's going to equal molarity of the base, which is 1 molar, times volume of the base, which is 18 milliliters, times the number of hydroxides, which in sodium hydroxide, I just have 1 hydroxide. So I'm going to input all of that information. Now remember, when we do our molarity equation, we usually have moles over liters of solution. But since we have volume on each side of this chemical reaction, each side of this equation here, I can actually leave it in milliliters because that unit cancels out. So you don't have to convert to liters. You can leave it in milliliters here. So we get M sub A times 25 milliliters times 2 equals 1 molar times 18 milliliters times 1. And then on the left-hand side here, I get 50 because 25 times 2 is 50. And on the right-hand side, I have 18 because 1 times 18 times 1 is 18. And so to find the molarity of the acid, all I have to do now is divide both sides by 50. So I get my molarity or concentration of sulfuric acid is 18 divided by 50, which is 0.36 molar.